Hello friends, welcome to the channel Informational Compass. So we'll continue with the exercise 1.2. We have finished the solutions of exercise 1.2 right from question number 1 up till 5. So if you haven't yet watched or solved those questions, you may refer the previous video in the playlist. So okay, let's start with question number 6. So it has been stated as when b is equal to 2, 5 or 7, find a solution in terms of vector UVW to equation 4 different from the solution 101 mentioned in the text. So what we'll do is we'll find a solution to the vector equation. We will find a solution UVW to vector equation so that is U 1 2 3 plus V 1 0 1 plus W, that is 1 3 4. This is equal to 2 5 7. Okay, so we'll write this equation, this vector equation as a system of 3 equations. So writing the vector equation as system of 3 equations. So what we get the equations as U plus V plus W equals 2. Then 2U plus 3 W is equal to 5. Okay, and 3U plus V plus 4W equals 7. Okay, so I'll just, this is 1, 2 and this is 3. Okay, so if we add equation 1 to equation 2, so adding equations 1 and equation 2, we get, what do we get? We'll add these, so it is 3U plus V plus 4W, yes, is equal to 7. So this is same as equation 3. So we get equation same as 3. Okay, so what we'll do, therefore we can find combinations of these 3 equations, right? Okay, for example, here we can write equation 1 plus equation 2, and the addition of this will be subtracted from equation 3. This will give us 0, yes, for both sides. So thus the system has infinite number of solutions. Okay, infinite number of solutions. Okay, now from equation 2, we see that U is equal to 5 upon 2 minus 3 by 2 W, if we put it in terms of W. So if, for example, let's take W is equal to minus 2. So we get u equal to how much? Yes, we'll calculate it. So it is cancel plus 3. So 5 by 2 plus 3 is equal to how much? 11 by 2. Yes. Then by substituting this value of u, by substituting u is equal to 11 by 2 and w is equal to minus 2 in equation 3. What we get the value of v as? We get v equals how much? Yes. Can you calculate? We have equation 3 as, what is equation 3? 3u plus v plus 4w equals 7. Now calculate. So it will be 7 minus 3u minus 4w. Yes. So 7 minus 3, 11 by 2 minus 4 minus 2. So this is 7, 33 upon 2 plus 8. Yes, that is 15 minus 33 upon 2, which is equal to minus 3 by 2. Yes. So hence such u, v and w satisfy all the three equations 1, 2 and 3. Okay. And therefore the vector u, v, w equals, we'll substitute these values, that is 11 upon 2, v is minus 3 by 2 and w is minus 2. Okay. So this is another solution. Okay, of the given vector equation. Okay. So hence our result, we write the final answer. So there are infinitely many solutions, first of all. Okay. Then one of them is u, v, w equals 11 by 2 minus 3 by 2 and minus 2. Okay. So we are done with our question number 6. Now let's start with question number 7. So it is given that two right hand sides in addition to b is equal to 257, for which equation 4 can be solved. Okay. Give two more right hand sides in addition to b for which it cannot be solved. Okay. So how do we start? In order to find two more right hand sides in addition to b, we'll have to find the vector equation. Okay. So we'll write in order to find two more right-handed sides in addition to b equals to 257 of the vector equation u equals u 1 2 3 plus v 101 plus w 134 equals to 257. Okay, this is the vector equation such that, what's the condition? Such that the vector equation is solvable. Yes. Now let us consider the column vectors. Let us consider column vectors. So what are the column vectors? Namely, what is v1? v1 is equal to 1, 2, 3. v2 is equal to 1, 0, 1. And v3 is equal to 1, 3 and 4. Okay. So now let us first show that these vectors they must lie in the same plane. So lie in the same plane. So for this, what we'll do, this means we have to what we have to prove that there exist non-trivial solution. Okay, the non-trivial linear combination there exists non-trivial linear combination of those vectors, yes, that equal 0. Okay, so how we'll write the equation as? Yes, we'll write it as in this way. Alpha, let's take alpha. So it is 1, 2, 3 plus beta 1, 0, 1 plus gamma 1, 3, 4 equals 0. Yes, which infers, now we'll form the equations alpha plus beta plus gamma. Next one is 2 alpha plus 3 gamma, 3 alpha plus beta plus 4 gamma. Okay, alpha. This is equals 0. Yes. So now using this, we get equations. Yes. I'll rewrite the equations. Alpha plus beta plus gamma equals 0. Then 2 alpha plus 3 gamma equals 0. Then 3 alpha plus beta plus 4 gamma equals 0. So this is 2, 3 and 4. Okay. Now here if you observe, if we add 2 and 3 and then we subtract it with 4, this would imply 0 equals 0. That is, we get 0 here, which implies there are, yes, there are infinite number of solutions. Yes, so infinitely many solutions. Alpha, beta, gamma that satisfy, yes, the system. Yes. So let's take an example. Let's take gamma is equal to 1. So what we get, alpha and beta is equal to, so alpha will be equal to, yes, alpha will be equal to, right, from equation 3, what we get alpha, yes, it will be minus 3 by 2, yes, and beta, it will be, yes, you can calculate this, it will be equal to half. Okay, so for alpha, beta, gamma equals minus 3 by 2, half, 1, we have, what do we have? We can directly write the like vector form. So it is alpha into v1 plus beta into v2 plus gamma, that is 1 into v3. It is v3, 1, 3, 4, I guess. Yes, 1, 3, 4, which is equals 0, 0, 0. Okay, so this is our first part. We are done with the first part. Now, the second part. So what does the second part state? That if we want, now this second part, if we want to find two more vectors, yes, it's in accordance with the question which has been asked. So if you want to find two more vectors beside b is equal to 2, 5, 7, that gives solution to vector equations. Yes, we have solved this. The solution to vector equation. What is the vector equation? 1, we have written it above. We simply, what we have to do? We have to simply find the vector that lies in the same plane as v1, v2, v3. So we'll write here in full sentence so that you will be able to infer it. We simply, what do? We simply have to find the vector that lies in the same plane as the column vectors. Okay, v1, v2 and v3. Okay, so two such vectors are v1 plus v2 plus v3. We can add this up directly. So it will be equal to, yes, you can refer this v1, v2, v3. This is v1, this is v2, this is v3. Okay, so add up all of these. So it is 3, then 5, then how much it is? 8. Yes, and similarly v1 minus v2 plus v3. Okay, so tell me after calculating, or you can pause the video to calculate this. So the solution is 156. Okay, yes, so we have got this part. Now comes the next part. So this is a lengthy question. Be prepared to write a lot. Okay, so now if we want two more vectors that do not give a solution, the earlier one was that gives a solution. Okay, now if I'll write it in full sentences so you will be able to complete your assignments if you're given. So if you want to find two more vectors besides b is equal to 2, 5, 7 that do not give, yes, that do not give solution to vector equation and to vector equation 1. Yes, so what we'll have to do, we have to find vectors. We have to find vectors that do not lie that do not lie in the same plane as the column vectors. What are the column vectors? v1, v2 and v3. Yes, okay, so now we know that v3 can be written as 3 by 2 v1 minus half v2. Yes, so therefore for x, y, z such that x comma y comma z is not equal to alpha v1 plus beta v2, thus that alpha comma beta belongs to R. Yes, is not equal to this, so this is also not equal to alpha plus beta. Yes, then 2 alpha. Yes, then 3 alpha plus beta. Okay. Yes, we are simply substituting these values. V1 was, yes, V1 was 1 2 3 and V2 is 1 0 1. We have simply substituted this value and we have got this answer. Okay, so there's no need to worry. Since V1 V2 given above. Okay, I'll just write it. You can write it in the given reason. Okay, so two such vectors are then, two such vectors for example are, one is 2 1 1, yes, and second one is 1 2 2. Okay, so we have got this. Very good. Now what we write the result as? Always write the final result, because the reason being that it's a lengthy question, right? So it has certain parts, so you'll have to write the result. That would be really great. So two vectors, so it can be summarized. Yes, the two vectors for the right hand side, so I'll write RHS, right hand side besides B. What is B? 2 5 7, for which equation can be solved 3 5 8 and 1 5 6, right? So we have done this. Okay, so this is our first part, 2 5 7, and the second part we have done it. Okay, 2 5 6, we'll have to just change the pro. Yes, this is 2 5 6, I'm not wrong. Yes, this one is 2 5 6. Please rectify this. Okay, 1 5 6. The solution is same, no worries about it. That's just the right typo mistake by, yeah. Then the second one is two vectors for RHS besides P is equal to 2 5 6, for which equation cannot be solved with, what are those? That are 2 1 1 and 1 2 2. Yes. Okay, so we have solved question number 7 as well. Okay, so now let's jump to question number 8, right? So we have completed question number 7. Now we are left with question number 8. Okay, so what does question number 8 give us? Question number 8 is explain why the system is singular. Okay, by finding the combination of the three equations that add up to 0 equals 1. Okay, what value should replace the last 0 on the right hand side to allow the equations to have solutions? What is one of the solution? Okay, so first of all we'll consider let us consider, just a minute, I'll just adjust this. Yeah, so let us consider the following system of equation. What it is? Oh, will that be okay if I just write it here itself? 1 2 and 3. Okay, so here if you observe, if we add 2 and 3, so we get How much do we get? Okay, just a minute. Let's add 1 and 3. Yes, so it will be 1 and 3 is u plus 2v plus 3w. Yes. So 1 plus 3 and then minus 2. So what does this give us? This gives us 0 equals 1. Yes, true. How? Because this had been subtracted and this one is 2 minus 1. Okay, I'll just write it here. 1 plus 3 is, add it. So it is 1 plus 2v plus 3w, which is equal to 2. And the second equation is u plus 2v plus 3w equals 1. So if we subtract this, yes, we get 0 is equal to 1. So this is what we have got. Okay. So therefore the system is singular. Yes, therefore the system is singular. But now there's a condition. But if we take for RHS in equation 3 to be minus 1, okay, instead of 0. Yes, then we'll have 0 equals 0. Yes, this will imply 0 equals 0 instead of 0 equals 1. Okay, this implies this system of equations has infinitely many solutions. Yes. Okay. Now, let us find one possible solution. Okay. So, what we'll write? Again, consider to find one possible solution. Okay. So, using the system, I'll write it. I'll write the system again. So, that is u plus v plus w equals 2. U plus 2v plus 3w equals 1 and v plus 2w equals minus 1. Here what we are doing, we are taking minus 1. So we have the equations 4, 5, 6. Okay. So what do we get from equation 6? V is equal to minus 2w minus 1. Yes. And if we substitute this value of v in equation 4, I'll write substituting value of v in equation 4. So what do we get? We get u plus v plus w equals 2. This implies u plus v is minus 2w minus 1 plus w equals 2. Yes, this implies, yes, can you solve it? U minus 2w plus w is minus w. Yes, minus 1 equals 2. Okay, so what we get? U is equal to 3 plus w. Yes. Now since there are infinitely many solutions, there are infinitely many solutions. What we may choose, we may choose whatever we want for w. Yes. So any value for w will satisfy. Yes. So let's take, let w is equal to 0. So therefore we get u is equal to 3 and v is equal to minus 1. Okay. By just substituting in these values, u and value of v. Okay. So by substituting w is equal to 0 in these two values, we have got u and v. Yes. That means one of the possible solutions of equations 4, 5 and 6. So therefore one of the possible solutions for equations 4, 5, 6 is which one? 3 minus 1, 0. Yes? Got it? I hope you have understood this. So let's write the result. Yes, that's important, right? Always write the result if it is a lengthy question. It's a good habit. So what is the first result? By taking linear combination, okay? By taking linear combination of equations 1 minus 2 plus 3. Yes, this is what we did. We get 0 is equal to 1. Yes, which proves the singularity of the system. Yes, which proves the singularity of the system. Yes. So for the value, I'll write the value again. U plus V plus W is equal to 2. U plus 2V plus 3W equals 1. And V plus 2W equals 0. This is 1, 2, 3. Okay, I'll write it again. Just a minute. 3W. Okay. And what is the second result? Yes, the system. Which system? The system U plus V plus W equals 2. U plus 2V plus 3W equals 1. And V plus 2W equals minus 1. They have infinitely many solutions. Okay. And one of the possible solutions we have found out. Okay. And one of them is 3 minus 1, 0. Okay. So we have got this, right? Now we have solved question number 8. Okay. We are done with this. Now let's go to question number 9. Okay. So now let's start with question number 9. On the column picture for the previous exercise singular system is this. Okay. Show that the 3 columns on the left lie in the same plane by expressing the third column as a combination of the first two. Okay. And what are all the combinations if B is a 0 vector? Okay. So let's first consider the column picture. Consider the column picture. Okay. What is the column picture stated as? U 1 1 0 plus V 1 2 1 plus W 1 3 2 equals B. Yes. Now to show that these columns V1, V2, V3, that is this one, 2, V3, lie in the same plane, what we'll have to do, we'll have to find the linear combination of these columns. Yes, that yields 0. Okay. In other words, if you want to, okay, I'll start writing. So to show that the columns, which columns? V1 equals 1 1 0, V2 equals 1 2 1, and V3 equals 1 3 2. They lie in the same plane. That is, we have to find the linear combination. Yes, linear combination of those columns. Am I right? Those columns that yield 0, or what we have to find? We have to express, basically. We have to express one of those columns, one of these columns, as linear combination of other two columns. Yes? Yes. So let us express V3 as, so V3 is equal to alpha V1 plus beta V2, where alpha comma beta belongs to R. Okay. So then what you'll have, this would imply alpha V1 is V1 is 1 1 0 plus beta is equal to 1 2 1 plus gamma, sorry, not gamma, my bad. Okay, so this is equal to 1 3 2. Yes, so this would imply alpha plus beta, then alpha plus 2 beta, and then beta simply. Solve with me, okay, if you are able to understand, because all of these examples are based on the previous ones, so we know what are we doing here. So try to solve this on your own, okay. So beta is equal to 2 and alpha plus beta is equal to 1, so this implies alpha is equal to 1 minus 2 is minus 1. Yes, so therefore we have what we have, V3 is equal to minus V1 plus 2V2. This implies minus 1, yes, into 1 1 0 plus 2 1 2 1 is equal to 1 3 2. Yes, we simply depicted this as this. Alpha is minus 1, beta is 2, yes. That is alpha into V1 plus beta into V2 is equal to V3. This is what we have written, okay. So therefore, the third column, yes, the third column is a combination of the first two columns. Yes, okay, so we have proved this. Now we come up to the second part. Okay, I'll just change this color so you will be able to grasp it in a much more better way. So now we come to the second part. Now let's find all the solutions UVW of the, I'll write it, U110 plus V121 plus W132 equals 0 0 0. Okay, so this is our vector equation. So we have seen that we were able to express V3 using V1 and V2, yes, in the previous part. So what was that? From above we get minus V1 plus 2V2 is equal to V3, yes, which is equivalent to my I'll write it as, okay, I'll change the signs, basically V1, okay, minus 2V2 plus V3 is equal to 0. This is right. So this would imply, what is the value of V1? 110 minus 2, yes, minus 2, what is it? Minus 2, and V2 is 1 to 1, 1 to 1 plus V3 is 1 3 2 equals 0. Am I right? Here what did we do is simply we wrote as this, okay. So hence what do we get? The solutions for V1, no, sorry, the solutions for UVW as. So therefore the solutions for UVW are UVW equals 1 minus 2 1 and UVW equals 0 0 0. This is default. Yes, this is by default. Yes. Now note one thing. We could have solved the equation 1 by transforming it into the system of 3 equations, but that would just give us the trivial solution. Yes, that is 0 0 0. But this is by default. So we could have easily, we have guessed it easily by simply looking at it. On the contrary, other solution would not have been given in this way, right? So we have got this. Okay, so the final result will be written as, I'll just write it. So the result is, first one is minus 1 1 1 0 plus 2 1 2 1 is equal to 1 3 2. And second one is u comma vw is equal to 1 minus 2 1 and uvw is equal to 0 0 0 are all solutions for u110 plus v 121 plus w 132. Okay, is equal to 0 0 0. Yes, so we have got this. Very good. So now we have solved question number 9, I guess. Yes, 9. So now let's solve question number 10. Okay, so under what condition on y1 y2 y3, okay, does the point 0 v y1 y2, okay, lie on the straight line? Okay, okay, okay. Fine. So one, take this one. Okay, so we know the equation of the line. Equation of line is y is equal to mx plus c. Yes, so we have y1. For y1, x is 0. Okay, so for y1 it is m into 0 plus c. This implies y1 is equal to c. Okay, so what we'll do is we'll simply plug in this point. What is it? 0 comma y1 and solve for c. We have to find c, the value of c. Okay, now what I'll do is, let's take, this one was my first point. Now second point comes as y2 is equal to m into 1 plus c. Yes, and what is, let's take y2 is equal to m plus c. And what is m equal to? Y2 minus c. Yes, and c is y1. Yes, from 1. Okay, so we have got, okay, now we'll plug this point. So therefore plug in point 1 comma y2 to get equation for m. Are you getting it? Now y3, what is it equal to? The third point, it is equal to m into 2 plus c. Yes, so therefore y3 is equal to 2m plus c. Therefore m is equal to y3 minus c upon 2. Am I right? And what is c? It is equal to y1 upon 2. Okay, now here if we see this part and this, we'll equate these two. Okay, so what do we get? Hence m is equal to m. So therefore y2 minus y1 is equal to y3 minus y1 upon 2. You got this from these two, this and this. Okay, so we are equating these. So therefore 2y2 minus 2y1 is equal to y3 minus y1. Okay, so this implies 2y2 minus y1 equals y3. So this would imply y3 is equal to 2y2 minus y1. This is what we get. And this is the result also. This is the final answer. Got it? I'll just write it again. y1. Okay. Got it? So this is question number 10. Now what we'll solve for question number 11. Will that be okay? Okay, so let's solve question number 11 also in this video itself. Okay. So here we have the equations ax plus 2y equals 0. Let's take this as 1. 2x plus ay equals 0. Let's take this as 2. Okay. So from equation 2, what do we get? X is equal to, it is equal to minus ay upon 2. Am I right? So when we substitute this value of x in 1, so therefore 1 implies, what does it imply? Okay, we'll write it. So minus a into ay upon 2 plus 2y equals 0. So this implies we'll take y common. So it is 2 minus a square upon 2 equals 0. Okay, so this gives us two outcomes. What are they? I'll write it down. So the first outcome is y is equal to 0 and therefore x is also equal to 0. Yes, this one is already known. Okay, got it? Now second one is 2 minus a square upon 2 is equal to 0. Yes, so let's consider this one. So let's consider 2 minus a square upon 2 equals 0. So therefore 2 equals a square upon 2. Therefore a square is equal to 4. Yes, so therefore a is equal to plus minus 2. Am I right? Okay, so now we see that, yes, we again got some outcome. So right now we see that, what do we see? We see that a is equal to 2. This implies 2x plus 2y is equal to 0. Yes, this would imply y is equal to minus x. Yes, and for the second outcome, a is equal to minus 2. If we substitute, we get minus 2x plus 2y equals 0. This implies y is equal to x. Am I right? So therefore, we have two lines of solutions. Okay, namely, what are those? First one is y is equal to x for a minus 2 and y is equal to minus x for a equals 2. Okay, this is our result also. Okay, you have to write the same thing in the result. For a is equal to 2, that is y is equal to minus 6, and for a is equal to minus 2, y is equal to x. Okay, so we have solved exercise 1.2 question 11. Okay, now let's complete question number 12 as well. So yes, what does question number 12 state? Starting with x is equal to x plus 4y equals 7. Okay, find the equation for the parallel line through x is equal to y, x is equal to 0 and y is equal to 0. Okay. Oh, this is quite lengthy one. Okay, let's solve this. It will take some time. No worries, we'll solve it. So let's consider, this is first part. So let us consider the equation x plus 4y equals 7. We can write it in the form of y is equal to, this will be 7 upon 4. Okay, so that will be equal to minus 1 upon 4x plus 7 upon 4. Am I right? So this is it. And for parallel lines, so we know for parallel lines, have same slopes. Yes. So in order to find a line y is equal to ax plus b that is parallel to x plus 4y equals 7, they have same slopes. Yes. So this implies, I'm sorry, alpha not a. This is a. This implies a is equal to minus 1 by 4. Yes. Inferring this, y is equal to mx plus c. So m is the slope. Okay. Now, what we have to find? We have to only find the value of b. Yes. So now, to find b, what we'll use this equation. So therefore y is equal to minus 1 by 4x plus b passes through 0 comma 0. Yes. So we have, what do we have? We have 0 equals minus 1 by 4, 0 plus b. This implies b is equal to 0. Yes. Okay, so therefore line that passes through 0 comma 0 and is parallel to x plus 4y equals 7 is given by y is equal to minus 1 upon 4x. Okay. So our first part is solved. Now for the second part. Now what we have to find? We have to find the equation for the line. Now we have to find equation for a line that intersects line x plus 4y equals 7 in 3 comma 1. So there are infinitely many possibilities for this. Yes. For such lines. Am I right? So let's consider a line that is perpendicular. So let's consider a line that is perpendicular. Okay, perpendicular to line x plus 4y equals 7 in point 3 comma 1. Okay, so then we know that the slope of that line y is equal to ax plus b is given by a is equal to 4. Yes. And a is equal to minus 1 upon minus 1 by 4, right? Am I right? So like in other words, what does it mean? Negative multiplicative inverse of the slope of the line to which it is perpendicular. Yes, this is what it means. So since that line also passes through 3 comma 1, we have, what do we have? We have 1 is equal to 4 into 3 plus b. Simply substituting the values. So 1 minus 12, that is equal to minus 11. This is the value of b. So therefore, we get the answer. So therefore, one example, because it has infinitely many solutions. So any one example for a line that meets with line x plus 4y equals 7 in a point, which point? 3 comma 1 is y is equal to 4x minus 11. Okay, now we'll write the final answer. So what is the final answer? So there are two outcomes. First, line parallel to x plus 4y equals 7 through the point 0 comma 0 is given by y is equal to minus 1 by 4. And second one is line that meets with x plus 4y equals 7 in a point 3 comma 1 is given by y is equal to 4x minus 11. Since there are infinitely many such lines, so on just one example. Okay, so this is the final answer for question number 12. Okay, fine. So now do you want, okay, so let's also solve question number 13 if you want. Okay, so problem 13 and 15 are a review of row and column pictures. Okay, so let's continue this in the second lecture, in the next lecture. So we have completed the solutions right from question number 6 to question number 12 in this video. Okay, so let me know if you have some other doubts or you want solutions for some other books, so I'll also start solving them for you. Okay, and please support the channel, please subscribe to it, and if you like the content, please like the video and press the bell icon so you will be notified if any video comes. It will pop on your home screen so you will be able to watch it. Okay, and if you have any suggestions for us, you can let me know in the comment section or you can mail us. So we'll try to come up to your expectations. Okay, thanks a lot. Bye bye, and all the best. Thank you.